Hi there, and welcome to today's class. Let's proceed in the study of differential equation. Last class, we dealt with the introduction to differential equation, in which we look at, or perhaps we dealt with some concepts such as definition of differential equation. We looked at some basic terms involved in the study of differential equation, such as the ordinary differential equation, degree of a differential equation. We also look at linear or non-linear and the homogeneity of a differential equation. What we discussed in the last class, right? So if you are interested in watching the previous class under the introduction to differential equation, so I will leave a link to previous class to differential equation in the video description. So check the video description. You see a link that will take you to a previous class on differential equation. So let's go through the study of differential equation from scratch. So let's proceed with the next concept called solution of a differential equation. Now, here's the idea. The key word or the important thing to note when it comes to solution of a differential equation is that every differential equation has its own process of solving it. That's why you can hear the word solution of a differential equation. So there are different ways, different perspective of solving problem under the differential equation. It's not just a method. No, there are several methods. That's why we have what solutions of what of differential equation. What are some of these equation? Sorry, what are some of these solution of a differential equation? Please, the word DE means differential equation. The first number one there, the first one number one there is given as direct integration method. All right, direct integration method. This is the first solution of a differential equation called the direct integration method. So there are some differential equation that the method you need to apply to solve that DE, that differential equation, is to apply what? A direct integration method. How do you know when you are meant to apply it? I will show you as we proceed. Number two there, the second one, number two there, is called the variable separation. Variable separation method, or variable separation method. This is second solution process of a differential equation. Number three there, number three is substituting y as being equal to vx. All right, please, this number three is not actually a method, right? There are some cases that the differential equation given, you can't use direct integration to solve it. You can't use variable solution. You have to change y as being equal to what? The vx. So that case is a case under what? Substituting y as vx. Please know this concept. I'm saying this is not a method. It's just a technique of approaching some problems under the differential equation. There are some equations that you can't use number one and two to solve it. So you have to change y in the question as being what? There as being vx. That's the task there. So this is number three, the third solution of a differential equation. The fourth one there, number four, is called use of integrating factor. Integrating factor. All right. That's integrating factor, IF. So there's some problem under the differential equation that you need to use integrating factor. And when it comes to integrating factor, there are four cases there. We have case 1, case 2, case 3, and case 4 under integrating factor. How do you know how to apply integrating factor? We'll look at that much more later. Now listen and listen, please. I'm saying this, that there are some problems or questions, if you are given some questions that cannot work for 1, 2, and 3, what do you use there? You use what? Use what? Integrating factor, IF. I will show you how this stuff works. When you see a question, how do you spot out that this question, oh, I'm using the first method, second method, or the substitution method, or the integrating factor? How do you know? I will show you as we proceed much more later. Finally, this one here is not a method too. It's just a process. It's called, number 5, it's called exact equation. So there's some part that will give you they say find the exact equation. So we look at that much more later. These are the solutions of a differential equation. So look at this concept one after the other. We look at this concept one after the other. So for this class, we'll start with the first one called the direct integration method. Let's look at the first one called direct integration. Number 1, please. Let's start.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen.
The first one called the direct integration method. All right. Direct integration method. All right. So let's start with the first one. First solution of a differential equation is called the direct integration method. So let's start with this place. Now listen and listen. When it comes to direct integration method, this method is only applied when you have the y over the x as being equal to f of x. Now hold on please. Look up. Let's do an illustration to this please. Let's say I have y is equal to s cubed, for instance, s cubed. I know very well that the y over the x is equal to 3x squared. All right. Now, after differentiating y with respect to x squared, my value gives about 3x squared. I know this. Now, here's the idea. From y, here's the idea. If I have this, so let's say this is a question now. For instance, let's say this man. Let's say this now. This is a given question. We are asked to take this answer back to y. Like from this answer, can we get this equation back? Yes. Now we said integration is the reverse of what? Differentiation. So here's the idea. If I have an answer of differentiation, if I integrate the answer, I'll get back what? The differentiation value back. So if I integrate this stuff here, if I integrate this one here, I'll get back this y back. So here's the idea. We said integration is the reverse of what? Differentiation. That is, if I get a differentiation answer such as this, and I'm asked to take this stuff back to this, what do you do? You integrate. You integrate. Now, by now, you should know about integration. You can leave this class now, and go back to integration playlist on my channel. Go and watch, go and learn before you come back here. Here, we are going to apply integration here. Now, here's the idea. I'm saying is that let's assume that I'm given this question, the y over the x is equal to 3x squared. I'm asked to go back to y. Yeah. What do you do in that case? First task, take the x to this part here. That gives you the y is equal to 3x squared. We said bring this the x. Yeah, that gives you the x. It's easy. Direct integration always come in this format. The y over the x, we go to what? Something with x. I'll show you as we proceed. From here, if I take the x here, I have this one here. My next task is integrate through. So integrating through, integrating through, through. This one gives you the integral of dy is equal to the integral of 3x squared dx. If I integrate dy, of course, I'll have y. Please go and watch integration. If you don't know all this, go and check the playlist. Okay, I'll leave a link to integration full course, full tutorial video in the video description. Go and check it. You should know if you should know this by now. If I integrate the y, I have y. Please. All right. This is now equal to. If I want to integrate this, what do you do there? It's easy as this. This one here is a method of what? When it comes to integration, there are basically three methods there. The first method is called the general method. Second method is called the solution method. Third one is called integration by partial fraction. Right? This one here is a case under general method. So go and check general method integration video. It's easier, as we said, to solve problem of this nature. Bring out constant term outside the integral sign. This one here is 3. It's constant term. That becomes 3 integral of what? X squared dx. So integration of this nature, we said bring out constant term. A constant term is a term that is not x. 3 is not x. Bring out 3 outside integral sign. So I have 3 outside this way. I have the integral of x squared dx left. From here, let's proceed, please. All right, take this one off. If I want to proceed from here, this one gives you y has been equal to, this is 3, into, please, if I integrate s squared, what I have, I'm assuming that you all know integration, please, so that it won't stress me much. Because if I integrate s squared, what do we know? We said add 1 to the power, that's the rule. That gives you x squared, add 1 to the power, all over, whatever you're adding in the power, this is 2 plus 1, put it as here, as 2 plus 1. That's all. Then add what? Plus c. Plus c is called constant of integration. Integration constant. This one gives you y is equal to, multiply this gives you 3s cubed over 3 plus c. This one gives you 3 cancel 3. I have that y is equal to s cubed plus c. Now watch. I was having this expression. Yeah, I now took this stuff here back to this original question. Observe. So here's the idea. If I have a differentiation question this way, I now differentiate it. If I want to use that differentiated value to go back to original question, I what? I will integrate. Integrating this answer now, I now go back to what? My original question. Please, we said plus c is constant. Right? It's constant. So that's how this concept works. So I'm saying this, please. I showed you this stuff because we're going to be using this idea and technique I just applied now in solving much more problem. So let's focus now on direct elimination method. Hi there. Are you a candidate for the upcoming 2026 JAM/WAEC examination? If yes, then I want to invite you to my JAM and WAEC tutorial class. In this JAM and WAEC tutorial class, we'll be looking at several topics such as mathematics, chemistry, and physics. For each of these topics, we'll be doing an in-depth teaching as well as solving past questions for the last 10 years for each of these topics. If this interests you, do well to click on the link you will see in the video description, or you can message me up through my WhatsApp number as displayed in front of you. See you guys in the next class, and welcome to Excellent Link Academy. Okay, let me take this part down. Let me take this one down. All right, take this down. All right, take this down. Okay, from here, please. Now, I want while here. So from here, please. Given a function, given a differential equation in the form of given a differential equation in the form dy over the x is equal to f of x. Given a differential equation in the form this dy over the x is equal to f of x. Now, listen and listen. Please note this. Note. Please note this in your book. Please note. Now, listen. Direct integration method for any differential equation is applied when you have dy over the x to be equal to something of x. Check. I have dy over the x equal to something of x. You apply what? You apply what? Direct integration method. So I'm saying this that direct integration method is only applied when you have dy over the x being equal to something of x. You apply what there? You apply a direct integration method. Let's assume that this is my question now. So I said, given a differential equation in the form of this, please, what do you do? Said, take this x here. That gives you dy equal to f of x. Take the x here. That gives you the x. Follow the same pattern of this process. You said you integrating through from here. Integrating through. Integrating through. That gives you the integral of dy equal to the integral of f of x dx, right? If I integrate the y, of course I'll have y to be equal to, let's assume that if I integrate f of x, I'll have d of x. I'm assuming, please, I'll have d of x. If I integrate this stuff here, let's assume I'll have d of x. Of course, I'll have plus c. This is the required solution of the differential equation. So this is the required solution of the differential equation. This is how you solve problem when it comes to direct integration method. Your first task, ensure that that question is having the y over the x equal to something of x. How do you solve it? Take the x to the other side. When you're done with that step, you what? Integrate through and then you solve and then you have your answer. Let's take some example under the study of solution of a differential equation focusing on direct integration method. All right, so let's list out the examples we'll be going through in the study of direct integration method. Let's list out the examples we'll be going through in the study of direct integration method.
Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It's of course 1,000 naira, or you go for the other level student to have access to both, right? So once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.
Let's write out this example and let's start solving these stuffs one after the other. All right, example one. All right, example. So number one, we're looking at number one. That's so evaluate the following. I have number one, dy over the x is equal to 5. Question one. Question two says dy over the x is equal to cos 2x, of course, plus 7. Question 3 says x squared, sorry, x cubed plus 4x squared plus 7x minus 3. I have dy is now equal to, like, this equal to should be here. Because of space, I have to bring it here. So equal to should be here and continue. So equal to 3x squared plus 8x plus 7 dx. All right. Question number four, I have dy over the x is equal to x exponential x squared all over 1 minus exponential x squared. All right. Question number five question, I have dy over the x is equal to x squared plus 2x all over the square root of x cubed plus 3x squared plus 5. All right, I have this. Next up, number 6, I have dy over dx is equal to 4x all over x squared plus 1, of course, all squared. Question number 7, I have dy over the x is equal to 2x plus 7 all over x squared plus x plus 7. All right. Number 8, I have dy over the x is equal to ln x. Number 9, I have dy over the x is equal to 2x plus 3 all over the square root of x squared plus 3x plus 1. Finally, number 10. This one says, so I have dy over the x is equal to x ln into x squared plus 1 all over x squared plus 1. All right. These are the example we are going to be carrying out in the study of direct integration method. We're looking at 1 to 10. I purposely bring out all this so we can be really groomed, right? When it comes to direct integration method, so this thing is crazy, right? It's really crazy. So some people among you say, I know this method very well. Like, I know this method. You go to your textbooks, you go and solve number 1 and 2. You assume you have know everything. Why can't you solve number 15 and number 20? Yeah, go and solve number 15 and 20 and see if you have know it. Some people, they'll teach you in class, you go home and go and carry number 1 and 2 and do. This I have known already. You left number 15 and 20 undone, right? So it's a stuff that you have to practice very well, so you're familiar with it. So I can't say I'm giving you only number 1 now and I will go to that method. What about this? How do you go through them? So you have to be familiar with more of the questions. If I'm done here teaching you, go search for that question and solve, right? Solve them, right? Solve them. Very important, please. So let's start with okay. So we'll look at the examples of the solution of these questions in our next video. If you like this video, do want to follow our next class, subscribe to this channel, and also leave a comment, right? Leave a motivating comment. If you also want, you can support our content creation. You can support our journey by donating to us or or you can follow our channel membership program, right? The link will be available in the video description, right? um that's basically all. So next class we'll start with the solving of these stuffs one after the other.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.